Yesterday we ran out of time and we couldn't finish after number 11. So I was only able to do the in number 11 first example with you. So we're going to do number 14. I'll show you a couple more so you can get a better grasp of how the slope, the tangent line, secant line, derivative, how all those come together using the difference quotient here. So we're looking for this function, the slope at 4/2. So you know that this here looks like this with a vertical asymptote at 2 and a horizontal asymptote at 0, y equals 0. And it has two branches, right? One going this way and one going this way. We're looking for the slope at 4/2. So maybe right here somewhere, okay? We'll see if that makes sense later. After we calculate, see if that expectation of our slope, like try to guesstimate that, right? See if we come close, okay? So let's do the first setup, which is finding the slope of the secant, which is f of 4 plus h, because we're plugging in for the x value that's given here, because we're looking for the slope at this particular point. Minus f of x, right, all over h. That's our setup. Now let's plug it in into our actual function that's given. So it's going to be 1 over 4 plus h minus 2. That's going to be when you plug in 4 plus h into this. Minus, right, f of 4, right, f of 4. Oh, I'm sorry. Here, that's what you were yelling at. I heard you. And 1 over 4 minus 2. Of course, you don't need to write any of this down if you do it in your head, as long as you don't make mistakes. All over h. All right, let's simplify this sucker here. I get 1 over 2 plus h, right, minus 1 over 2 all over h. Are we there? Good? So far? Now try to finish. I'm sure you can probably finish this without me. All right? Now, you see this ugly complex fraction, so I'm going to multiply by 2h, h plus 2, 2h, h plus 2, okay? So complex fraction, right? And I get 2h minus h plus 2, right? All over this whole ugliness, 2h squared, h plus 2. Now, try not to multiply everything out unless you need to later, okay? Well, you may need to, you may not, okay? Now, the numerator here, I can see that I can simplify this to 2h minus h squared minus 2h all over 2h squared, h plus 2. I left it. And I can see how later you'll become savvy enough where you're like, should I leave it or should I multiply all this out, right? Now I simplify this to negative 1 h squared all over 2h squared, h plus 2. But, right? So you can cross these out. So you're left with negative 1/2 h plus 2. I'm sorry, negative 1/2, so I'm going to take the negative away there. All right, so you're left with this. Now, at this time, this is when you're actually finding the slope, right? So you're going to find the slope of as h, the limit as h approaches 0. So as soon as you got this here, remember your second step is to find the limit, because you're doing this. Slope is equal to the limit, right, as h approaches 0 of your secant's slope. Remember how we went like this, secant, and then we went like this all the way down to the tangent line? That's what we're doing here, okay? So this right here is our slope of our secant. All right, now let's take the 0. So now plug it in, right? So you're pretty much plugging it in. So I get negative 1, 2, direct substitution, right? 0 plus 2. And what are you left with? Negative 1/4. And that, ladies and gentlemen, is the slope of our function at 4/2. And let's see if it makes sense. Negative 1/2, negative 1/4. It's definitely negative, right? And you don't need to guess the exact amount, but that's about what it should be. All right, does that make sense? All right, try that. And it's just like algebra, really, right? So now, what if this is another question to you? What if, like, for example, number 17, it asks you for this. It says, hey, now I want you to find the formula for the slope. They want you to find the formula for the slope of the graph, then use it to find the slope at 2 given points. So first step we're going to do is we're going to find the formula for the slope, okay? Because a slope, as you know, I mean, there's different slopes at different points, right? So if we find a magic formula that will work for every point, it's pretty powerful. So we're going to do the same thing. We're going to find the slope of the secant line of this guy here. And this guy, as you know, looks like this. Negative x root x squared, and it's positive 4, so it's going to go like that. It's a parabola facing down, and we're looking for the slope at 0, 4, right? So, oh, what's that? Okay, that's going to be definitely, yes, the slope is 0. How about negative 1, 3? It's about here somewhere, and it's about right here. So we're trying to find the slope there. Think about that, okay? Always know what you're doing. All right, now we're going to find out. Here, I'm going to do something a little bit different. So g x plus h, I'm actually applying the actual difference formula, right? I mean, so difference quotient, okay? Now, let's plug it into our function here. And notice, I don't have a specific x that I'm trying for because I'm going to find the magic formula and plug these in later to the magic formula. 4 minus x plus h squared minus 4 minus x squared. All we're doing is finding the g of x plus h and g of x, and then h. Now, when you simplify this, you should get something like this. I'll just write it all out, but you don't need to, okay? X plus h, 2xh plus h squared, right? Minus 4 minus x squared. So I'm not going to do the whole calculation here, but I'm going to just tell you that when I did this, I got negative h, 2x plus h, all over h, which came out to be negative 2x minus h, assuming that h is not 0. And also, we're assuming that the limit exists, okay? All right, and that right here is our formula. Because it's in terms of x, that means we can take in any kind of x variable. And I'm going to now we're going to use this to find all the limit, okay? Now, let's take the limit as h approaches 0 for your slope of formula for the secant slope, which is the limit as h approaches 0, negative 2x minus h, right? So now we get direct substitution here, negative 2x. And that is our formula, as they called it, okay? So now we're going to take this guy and plug in these coordinates here. So let's do for A right here. I'm going to do it a little bit here so you can see it better. 0, 4, right? So I'll just do it here, actually. So A was 0, 4. We're going to take this formula. So slope is equal to negative 2 times 0, which is 0. Ding, ding, ding. Does it make sense? Sure does, because it's a flat line. It's a horizontal line. Now let's do B. We got negative 1, 3. Okay, m equals, right, because that's our slope, right, you guys, that's our slope, right, m equals negative 2 and negative 1, which is 2. And it's checky. 2 at negative 1/3, that looks about a 2 right there, the slope, okay? All right, so that's powerful. Honestly, even if they give you a point, I like to actually find this guy here. This actually has a special name, which we're going to talk about in part 2. Oh, because a slope is actually another function, don't you think? It's derived from this here, our original function. I wonder what that's called. I wonder if the word derived is involved. Why, yes. Here's part 2, the derivative. Probably the most important thing in calculus is the derivative. One of the most important and it's one of the most concepts that you're going to talk about a lot in calculus, okay? The derivative, you're right, it's a derived function from the original function. It's been derived, okay? So remember, the previous example, we had something like this, right? We had 4 minus x squared. Well, we derived something. Didn't we derive that the slope was something like 2x, right? Ooh, okay. So think about that, okay? So you'll see how that's related. Let's go on. Okay. Oh, I'm sorry. I knew it. I was like, what's happening here? All right, now, let's go here. The derivative of f of x at x is. The derivative of f at x is, yes. You see this guy here with the little apostrophe here? That's not an error. That's actually, wasn't this our slope, you guys? We took the slope of our secant, and that was our slope, right? Slope of our secant, right? The limit as h approached 0 of the slope of the secant. It was a difference quotient, correct? That's actually the derivative. And you know how our original function is f of x? Well, the derivative is noted as f prime of x. Okay, that's one notation. So the derivative of f at x is f prime x equals limit as h approaches 0 of the difference quotient if limit exists. Also remember that the derivative f prime x is a formula for the slope of the tangent line, which is what we concluded here, to the graph of f at point x, f of x. Just remember the original opening of this lesson. You remember how we did secant and then we went to the tangent at the same point x, f of x. Now, here's some the notations for derivative, okay? Y equals f of x, and we have f prime of x. That's our most famous one, right? And we also talk about dy dx, dy over dx, dy dx. That's what we just call it, dy dx. We could also say y prime if you want to. D of dx of f of x, that's another way. Or capital D sub x and y here. So pretty much this is like a noun, right? This is a noun. This is also a noun. This is also a noun. But this right here and this right here, they're kind of verbs. It's like us doing something. Okay? We're going to use this a lot. The derivative, or I guess it's a slope of the function at a given point. That's how you can think of the derivative. So now they're going to ask you this. Like on number 25 and so forth, they ask you, hey, find the derivative of this guy right here. Okay, so in your head, you have an idea of what this function looks like, okay? But they want us to find the derivative. Now we're going to use the derivative, right, notation, and we're going to actually find the limit as h approaches 0 of our difference quotient of h. All right, now let's plug it into our original. I'm going to write limit as h approaches 0, and we're going to plug it into this function here. So I get 1 over x plus h. It's really no different than what we've been doing. X squared, right? All over h. Again, complex fraction, so I'm going to multiply everything by all this ugliness here. Okay, now what I'm going to do is to shorten the lesson a little bit. I'm not going to show all the steps. So when I simplify this, make sure you end up with this here. I'm going to do all the calculations here. I'm not going to multiply everything, but I'll just do the intermediate step here. I end up with this. Okay? Now, once I get to this stage, again, you notice that I didn't multiply this out. And you'll see why very soon, okay? Now, let's simplify everything. Limit as h approaches 0. Notice I'm writing this every time because you need to. And when I actually factor out and I end up with negative 2x minus h all over x squared, x plus h squared. Can you guys make sure that your algebra is correct so you got to this point? Okay? I know it looks like, well, how did she get from here to here to here? But I skipped a lot of steps. Now we're going to take the limit. We've done as much as we can. Now we do direct substitution, okay? So here's what I end up with. I'm going to do it here. I'm going to take the limit of as h approaches 0. So I'm going to go negative 2x minus 0 all over x squared, x plus 0 squared. And what do I end up with? Negative 2x over x to the 4th. But x goes away, so I'm left with the ultimate answer of negative 2 over x cubed. And this right here, my friends, is the f prime of x, a derivative. So this guy is a derivative. Your derivative of this original. So you notice that this has been derived from this guy, and it's the derivative, and this is the slope, basically, at a given point. So we wrote a function for the slope at any point on this curve, and here it is. And you can just plug in at any point. So we're going to try one more, okay? So let's try one more. Okay? Now we're going to try one more. Let's try number 29. Oh, number 29 is right here conveniently. Okay. Let's find the slope of this guy, and they want us to do more with it. Find the slope of the graph of the function at this given point, and then use the result to find the equation of the tangent line to the graph. What? What do they mean by that? Okay. So let's figure this out. And a tangent line, you saw, most cases, it's actually a y equals mx plus b. Or sorry, y equals mx plus b line, right? So if you have a curve, again, you know what this curve looks like, don't you? it's -1, right? That's where it starts, and it's a radical function like that. Well, 3, 2 is about somewhere here, right? 3, 2. So they want us to write a tangent line here, and this tangent is a linear, okay? So just keep that in mind. So let's do it again. Let's find the derivative. Basically, we're finding the derivative once again, so let's do it this way. Let's actually do fancy. When they ask you to find the slope, it just means find the derivative, right? So limit as h approaches 0, and we're going to do the same thing, f of x plus h. I always set it up so I never forget. All right, and now let's find the limit as h approaches 0 of this guy. So we're going to plug in, so let's actually plug in the 3 here in this case, okay? So square root of 3 plus h, right, plus 1, minus square root of 3 plus 1, right, because 3 plus 1, which is 4, all over h. And I simplify everything. I'm going to simplify everything, and here's what I end up with. Ready? Square root of 4 plus h minus 2 all over h. Now, I have to use the radical, right? I have to rationalize method. So I'm going to multiply everything by square root of 4 plus h plus 2, square root of 4 plus h plus 2. So now, simplify this on your own and turn on the video later to see if you got it correct. So I take limit of h approaches 0, and I end up with this, you guys. I do everything here, and I end up with 1 over square root of 4 plus h plus 2. Now, okay? Now let's take the limit, because I can't do any more, so let's see, as long as when you do direct substitution, it doesn't cause any problems, then you could go ahead and substitute. So I'm going to do direct substitution here, so I end up with 4 square root of 4 plus 0, because I'm taking the limit as h approaches 0, plus 2. So I end up with 1/4 as my slope. See if I understand that. So that's the derivative, or that's the slope. But now, I guess, you know how they asked you for the slope here? And I found the derivative? I guess the derivative is more like a function, so you should have an in terms of x. So I'll just write slope here to be more exact, okay? Because we're really looking for the slope, and this is the slope, not the function of. So the terminology is a little bit funky there, okay? Now here at 3, 2, so this is a slope for sure, and you know that it has to be somewhere like this, right? Right? Linear, but this is 3, 2. You're given a point and a slope, so let's write it into point slope form. So I got point slope form. Y minus y1 equals slope x minus x1, so I'm going to plug it in. Y minus 2 equals half x minus 3. When I readjust this equation to slope equals slope-intercept form, point slope-intercept form, I get 1/4 x plus 5 over 4. And that's the equation of the line of this function at this point, the tangent line. The tangent line, because this is the tangent line here, it's got a slope of 1/4, and this is the complete equation. Okay? Yeah. So you see how they're all related, okay? Now, I'm going to just demonstrate what they ask you to do for number 31. Okay? Number 31 kind of question. All they want you to do is, number 31, all they want you to do is figure out this, plug in these points into each of this function. You see how this is the original function and this is a derivative? See what you get for the values. And we're going to talk about those values next time I see you. Okay? Now, okay. I have another challenging question for you, number 37. Okay? Now, this question is a little strange. Use the derivative to determine any points on the graph of f where tangent line is horizontal. Horizontal. So imagine this graph. You know this graph is a cubic, right? It's a cubic. It goes like that, okay? And you know that it's at 2 places. Slope is 0. Slope is 0, okay? So I won't finish this question because I think the lesson is getting a little bit too long. Now, when you find the derivative using the difference quotient as limit as h approaches 0, f of x over h, okay? Now, what you're going to end up with, you're going to end up with something like this. 9x squared minus 9. 9x squared minus 9, okay? Now, think about this. This is a derivative, or this is the function for the slope of the line, the tangent line, on this curve. So think about what you would do with this information that you need to find. They want us to find the 2 points where the slope is horizontal, or slope is 0, or the tangent line is horizontal, okay? All right? So think about what you would do there, and then we can discuss that next time I see you. If you don't get to finish it because you're confused a little bit, it's all right, okay? But we'll see you later. Bye.